Hi everyone, my name is Krista Dietrich, and today for this presentation I'm going to walk you all through every step that is involved in generating acetyl-CoA from pyruvate. So first I'm just going to show you my little drawing here, and it goes through all of the steps here that I'm going to walk you through. So I'm just going to give a little summary first. So acetyl-CoA acts as a start point as well as a fuel for citric acid cycle. Acetyl-CoA is produced from pyruvate through a series of reactions. As we know, pyruvate is an endpoint of glycolytic pathway, and under aerobic conditions, pyruvate is transported to mitochondria by pyruvate OH antiporter. So the reaction takes place in mitochondrial matrix, resulting in the production of acetyl-CoA, which I have just drawn here at the bottom. See if that loads. Just the whole reaction there. And these reactions are catalyzed by a complex of enzymes called pyruvate dehydrogenase complex, which consists of pyruvate dehydrogenase right here, dihydrolypolytransferase, which is right here, and then dihydrolypolyl dehydrogenase here. Diamine pyrophosphate is also included here. Sorry if I'm butchering these names, I'm doing the best I can. In addition to these 5 cofactors which are involved, which is TPP like I just stated, lipic acid, FAD, CoA, and the NAD plus right here. And they're all stoichiometric cofactors. The conversion consists of basically 3 steps, which is the decarboxylation, oxidation, and then the transfer of acetyl-CoA. And the pyruvate dehydrogenase cannot complete another cycle until the dihydrolipoamide is oxidized to lipoamide, which is regenerated by dihydrolipolydehydrogenase by transfer of 2 electrons from FAD to NAD+. And then I'm just going to go through a little more in-depth summary of basically what I just stated. So in step 1, pyruvate is produced in cytosol and transferred to mitochondria, which I stated earlier, which is oxidative decarboxylation of pyruvate, and it takes place with the help of pyruvate dehydrogenase with an enzyme called TPP from temporary bond with pyruvate here, giving off a CO2. And then in step 2, which is over here, the enzyme dihydrolipotransacetyl helps to attach other molecules like lipoamide and TPP from the first step and is removed to form an acetyl group. And then in step 3, the CoA group attacks the acetyl group, which forms acetyl-CoA. And lipoamide is released in reduced form. Then in step 4, lipoamide is reoxidized with the help of dihydropolydehydrogenase, and it also, NAD, becomes NADH, which is right here, while oxidizing lipoamide, so that in the next cycle, lipoamide can be used. So here I'm just going to kind of zoom in on all that. Hopefully you can see it. I highlighted the main steps right here, 1, 2, and 3, and then within these small contexts are more of the nitty-gritty details, and then this is the acetyl-CoA right here. Anyways, I hope that made sense to all of you. If you have any questions or concerns, just feel free to leave a comment on the discussion board. I look forward to watching the other videos as well. Thanks.